You're listening to the Good Question Podcast with Richard Jacobs. Our goal is to make each of our guests exclaim, that's a good question. I don't know the answer. Because when that happens, it means you, the listener, may be inspired to learn more beyond the interview and to ask great questions yourself that lead to new insights. In this podcast, we cover historical and current anthropology, comparative religion, and history. Welcome, and let's get started.
Hello, this is Richard Jacobs. My guest today is Regents Professor Michael Sachs. He's part of the Sandra Day O'Connor College of Law. He's also part of the Department of Psychology at Arizona State University and a faculty fellow with the Center for Law, Science, and Innovation at ASU. So we're going to start our focus with a book that he's written on the area of forensics called Modern Scientific Evidence, the Law and Science of Expert Testimony. But first, I want to welcome Professor Sachs. So thank you for coming. How you doing?
Hello, I'm fine. Hope you are well.
Yeah, happy to talk to you. Before we jump in, tell me a bit about your background and how you got into the areas of study that you're currently engaged in.
Well, I'm a bit unusual in that I have a funny mix of fields. I started out going to graduate school in experimental social psychology. I got my PhD in that. I went off to be a psychology professor at Boston College. My research, though, tended to focus on legal issues, the legal system, law, and I came to a point where I thought I'd better go get educated in law. So I went to a special program at Yale Law School, which was for journalists and academics who did not plan to be lawyers, but felt they needed to learn some more law. After I did that, I started getting calls from law schools to switch over from being a psychology professor to being a law professor. That all happened back in the 1980s. So I am a little bit of a fish out of water, but I've been doing that for the last 30 years or so. Oh, and how did I get into this topic?
Yeah, what's your current area? Yeah, forensics.
Well,
I'm not sure what else that you're currently investigating.
Well, my main reason for existing in academia is to try to bring a better understanding and appreciation of the value of empirical research to lawyers. Usually it's law students, but I'm often invited to speak to judges and lawyers. In law, they don't learn how to do empirical research. They don't learn how to evaluate it. And yet so much of what they do depends on facts about the way the world works, about the way the legal system works, the kinds of things that political scientists and psychologists and sociologists spend more time worrying about. So I'm there to try to bridge that gap. And my academic research is various projects that try to bridge the gap in more real world areas. So here's the forensic science story. Back when I was living in Boston, I worked on a project with some other researchers who were asked by the Office of Technology Assessment, which many of your listeners have probably never heard of. It used to be the scientific consulting arm of the U.S. Congress. If Congress had an issue that came before them and they didn't just want to hear what the lobbyists wanted to tell them, they had their own independent consulting arm. That got wiped out at some point, probably in the 1990s, but they were concerned about polygraph examinations. And our job was to review all the research that existed on the accuracy of polygraphs. They used polygraphs not only in law enforcement, they used it in the military, in the Pentagon, to try to scope out spies. And were they really accomplishing anything is what they wanted to know. If they give periodic polygraph tests to their employees in the Pentagon or military officers to try to find out if any of them have become spies for any of our adversaries, were they really going to be able to find what they wanted to find? So we reviewed all that research and wrote a report. A little news item about that project wound up in probably the New York Times, and some lawyers in New York saw it, and they had been working on a case involving the Mayflower Madam. Your listeners, you've heard of
Sydney.
Yes, Sydney Biddle Barrows. She was a descendant of some people who came over on the Mayflower. And what made her the Mayflower Madam is she was suspected of running a high-level prostitution service. And turns out the customers of this enterprise were also rather high-level people. So it was one of the ironies of it was that if the prosecution had its way and was able to prosecute this,
who's who of clients, and that would be
yes, right. But the lawyers who got in touch with me were very interested in the problem of handwriting identification, because the only real link of the defendant, or let's say one of the most major links of Sidney Biddle Barrows to this prostitution ring, was a handwritten log of customers. And they wanted to offer into evidence a handwriting examiner from the police crime lab to testify, I'll say, as to whether it was her handwriting in this log. Her defense lawyers wanted to challenge the admissibility of the handwriting expert as not meeting the law's standards for what it takes to offer expert testimony. So they called me up and they said, could you do for handwriting what this team you were on for the Office of Technology Assessment did for polygraph examination? And I said, well, sure. What's involved is you go out, you find all the studies that you can lay your hands on that address the question of, in this case, the validity of the claim that handwriting examiners, and link the writer of a document to the writing on the document to the person who wrote that writing, and what degree of accuracy can they do it with. So they said, okay, we'd like to hire you to do that. And this is the kind of thing that academics do all the time. You go, although not for legal cases usually, but you find a bunch of studies and you review them, you evaluate them. Some of the studies are better designed than others, and you evaluate what you learn. What's the bottom line lesson that one can take away from such a review of the empirical research literature? Well, the big surprise for me was there was essentially nothing. I hunted high and low. I contacted some document examiners, handwriting experts, whose paths I had crossed previously when I worked for the National Center for State Courts. And you steer me to where is the research? This would be like a doctor, a surgeon who says, the right treatment for you for this disease is X. And you say, can I see the double-blind, randomized, controlled studies that test whether X is the best available treatment for this? They would say to you, sure, here are the reviews. But if you ask that of handwriting examiners, which very few courts ever did, and very few lawyers ever did, they would come up essentially empty-handed. There was exactly one study done by a law professor at Northwestern University in the it was either the late 20s or the early 1930s. And the most interesting thing and what he did is he recruited a bunch of handwriting experts and presented them with handwriting exemplars. Here's some...
Well, if you don't mind, one quick thing comes to mind. In today's world where people rarely write, I would guess that the new form of this, maybe you could look at the cadence that someone texts at. You know how sometimes misspellings get saved and certain autocorrects get saved in a person's phone, and it becomes kind of their profile, or their fist, I guess you can call it. I wonder if that's like a more modern form of, instead of handwriting analysis, but like electronics communication analysis.
It very well could be. That would be like an updated version, a little bit of an updated version of typewriting. They could also, and you've probably seen this in mystery movies, or at least old mystery movies, when they still had typewriters, One, there'd be a key or a letter that wasn't just quite right, and they'd find evidence of that in the ransom note. So there are various ways that you might be able to try. Well, the entire field of forensic identification is an attempt to look for variations in something that somehow let you connect it to the source of it, whether it's firearms, whether it's footprints, whether it's DNA, whether it's handwriting. But in this case, there really was no there. There's one study from early in the 20th century. The most interesting part of that one study was that the experts went out of their way to not turn in their reports, their opinions, their conclusions, because for the first time in their lives, you had somebody who knew what the correct answer was, who knew who wrote this particular 3x5 card. I think they were signatures. So you have signatures on different 3x5 cards. And then you have another packet of signatures, and you're supposed to match up who wrote which. If you get it wrong, someone's going to know you got it wrong. The way we do this in court, no one will know if you got it wrong, because you come in and you give your expert opinion. And if they already knew for sure who wrote it, they wouldn't need you anyway. You're there because no one knows, and they want you to tell them the answer. So this was the easiest report I ever got to write, which was there's really nothing out there to support the claims of the experts. So that kind of got me off and running, because that got me curious about other fields as well. I should say, by the way, that before that case was over, I got wind of some proficiency studies that were being conducted by some forensic science organizations, where they sent out what I'll call known quantities of manufactured evidence. They're not from real crime scenes, but it's easy enough to take a couple of guns and test fire them, and you either send a pair of bullets that were fired from the same gun or were fired from different guns of the same make, model, caliber, and ask someone at a crime lab, look at these, compare these, and tell me, were they fired from the same or different gun? Or paint chips, or fragments of glass. And the question is always, they don't like to use the term match, though that's what we hear a lot on TV and in movies, but do they match? Did this fragment come from the same place this other fragment came from? So suppose somebody breaks into a home and murders somebody, but the way they broke in is they broke a window. Then you arrest somebody and you vacuum their clothing for minute fragments of glass. You'll always find some on all of our outer clothing. And you take that glass and then you see if you can match its refractive properties, its chemical properties, something. Can you match it to that window? So,
well, how accurate are these methods? Like, what quantity of material is needed to get a true sample, and how accurate is the possible matching from this type of forensics?
Well, let me start with handwriting, because there are a lot of these proficiency studies that I then got my hands on. They weren't being published. They were being held privately. What you immediately realize when you start looking through them is that some handwriting identification tasks are much easier and some are much harder. And so there's no easy answer. In some of them, everybody who looks at it gets the right answer, including non-experts. Others, there was one test they ran where every handwriting expert, these are people who work in crime labs mostly in the US, but also Canada, they all gave the same answer. And they're filling these out independently. You send it out to their crime labs and ask them to do their usual analysis. They all gave the same answer, but they all gave the same incorrect answer. So that task was so difficult that they were all misled and they were all pointing at the wrong person. So what that tells you is there's a great deal of variability. There's going to have to be a lot of research to be able for the examiners or for a judge and a jury to know that, well, this is a situation where I can put a pretty high level of confidence in what the experts are saying, or this is a task that they shouldn't even be doing.
I've never heard with any kinds of forensics, oh, this method has an 84% false positive rate, and this one is a 20% false positive. Is anyone privy to that?
Usually the error rates are not.
That data even exists, error rates.
Well, as I've indicated, there are some of these tests, some of these exercises where the error rate on the one I described a moment ago was 100%. The agreement rate was also 100%. So if they all came to court and agreed with each other, the judge and the jury would be very impressed. But it turns out they were all wrong. Then there are others where 99+% of them get it right. So there's quite a bit of variability, and there had not been a lot of testing. There was, in a way, I think the lesson of this was that forensic science in the 20th century was operating in a very old-fashioned kind of 19th century way. We have a good idea here, and now let's go to court with it. The idea of looking for something like fingerprints that has a great deal of variability, so that if I find fingerprints at a crime scene, maybe I can match them up with someone. The bottom line answer seems to be, and this now matches up with late 20th century thinking, which is more probabilistic. You're never going to get that one-on-one, the one and only person or bullet or writing or even DNA, to the exclusion of all others in the world, so that we now know for a certainty that we've got the person. Instead, what you are able to do is narrow that pool and say, I can exclude 99% of the people, but I have a pool of people who cannot be excluded. And if we were doing, and this actually is how DNA evidence is presented, although most people aren't really aware of it, but they give random match probabilities. They calculate the probability that a random person in the community or the city or the state would have contributed material that matches as well or better than the suspect's contribution. So you can't rule it out. Let's take handwriting. There were eventually some studies of handwriting that found that, quite surprisingly, there were many people who wrote their signatures so similarly. So let's say so similarly you couldn't tell them apart. The way this person did that study was to go to voter registration lists. And this was in Los Angeles in the 1950s. And they found everybody whose last name was Brown. And so you have hundreds, maybe thousands of them. And then he looked at every one of those signatures, and this was a handwriting expert who did this, and said many of them were indistinguishably alike. So if one of those people committed a crime and left his writing at the crime scene, it would match him, but it would also match a bunch of other people.
Yeah, but how could you extrapolate that? A signature, like I know from my own signature over the years, I'm just tired of signing stuff, so it's just gotten crappier and crappier and crappier. So I don't think that signature would be a good proxy for how someone writes. And then also you have how often do people, as you're talking, I'm thinking of, when I go buy things now, those stupid tablets that say sign with your finger. Yeah. They're so crappy.
Right.
There's no, handwriting has been totally degraded, but.
Right.
But even if it wasn't, again, just trying to say, because someone's signature was similar means their whole handwriting was similar. I think that's probably an overreach.
Well, it used to be believed, first of all, I'm sure you are right, that everyone's handwriting has deteriorated a lot. We don't use our handwriting much anymore. Though handwriting examiners long believed that one's signature was the most unique, identifying writing that person would ever do. Well, that certainly sounds like it wouldn't describe your handwriting. It doesn't describe mine. And on those iPads, when you buy your coffee at Starbucks, or any of those really do a very poor job of capturing our writing.
What would be interesting, by the way, is if someone worked with the credit card companies, whoever, wherever these signatures go into the void, sometimes people do decorative things. So it would be cool to do, let's say, an art exhibit of the most 100 interesting images from a database of, 5 million quote unquote signatures on these iPads. I had just an idea that came to mind.
Yeah. Let me move to the big picture. There was a large review done by the National Academy of Sciences in 2000. They released their report in 2009, and they asked every forensic identification field and beyond that, like fire and arson is not identification, but it's a good example of some of the problems. But they asked people from the organizations of these fields to present them with any and all of the research that existed that tested whether their specialty, what they had to offer to courts, was valid or not. Here is the conclusion from that report. Quote, much forensic evidence, including, for example, bite marks and firearm and tool mark identifications, is introduced in criminal trials without any meaningful scientific validation, determination of error rates, or reliability testing. Forensic science professionals have yet to establish either the validity of their approach or the accuracy of their conclusions, and the courts have been utterly ineffective in addressing this problem. That conclusion, now that didn't suddenly lead courts to refusing to hear these experts, but what it did do was to lead a number of federal agencies like the NIST.
National Institute of Standards and Technology.
Yes, that in conjunction with the National Institute of Justice, in conjunction to a lesser degree with the Department of Justice, they have been working ever since then to promote research. They have hundreds of people that work on this, many of them from crime labs, many of them from academic laboratories, working to try to make forensic science more scientific and therefore more valid and have a better idea of how accurate it is or isn't. Some of these specialties will disappear. Some already have, by the way. There was a method of matching bullet lead, which used to be used and it's been thrown away. There used to be something called voice prints, where if a person called up on a phone and left a death threat or a bomb threat and it was recorded, they thought they could match the speaker. If they caught a suspect, they could match the suspect's voice to that recording. That got thrown out. Fire and arson had nearly 24 what were thought of as arson indicators that have been thrown out. What I mean about the arson indicators is you have a house fire, a warehouse fire, a building fire. When the fire is over and you investigate what's left, experts in fire and arson thought that they could see things in the remains of the fire that were indicative of it being set rather than accidental. And they came up with ideas. One idea was sometimes we see crazed glass, sometimes we don't. Crazed glass is where there's kind of a spider webby fractures in the glass. Sometimes we see spalled concrete. That's where a scallop-shaped bit of concrete has exploded out of a wall or floor. Sometimes we see it, sometimes we don't. And they invented ideas about why a set fire would produce, let's say, crazed glass, and an accidental fire would not. Their theory was with an accidental fire, the temperature would rise more slowly. With a set fire, it would rise faster, and the fast switch over from cool to very hot glass would cause the crazing. But it was just an idea, and they'd go into court and they would testify to those ideas. When they eventually got around to testing those ideas, and this is the real science part, we've got a hypothesis. Let's test it. When they started testing them, they found that nearly 24 of them were simply wrong, that they were unable to distinguish a set fire from arson, set fire from an accidental fire. Crazed glass, for example, they figured out eventually, after many using this in court for many years, and by now they should have stopped, because what they found out was the crazing of glass was the result of rapid cooling, not rapid heating. So if the fire department got there and sprayed water on the side of a burning building, when the water hit the glass would craze. If the glass was on the other side of the building and didn't get hit with the cool water, that glass would not craze. So that field still exists, but many of the indicators that it had relied on and gone into court with testifying about, those have certainly been thrown out by the official literature of the field. And I'm sure newer investigators are being taught the new and more correct knowledge. There might be some old arson investigators who still believe those old things. Another one, bite mark identification. You have, let's say you have the victim of a murder, and that victim has bite marks, presumably left on that person's body by the killer. Then you arrest a suspect. Forensic dentists claimed the ability to match the dentition of the biter, presumably the killer, to the bite marks on the victim. Texas has now thrown that out as invalid, or at least the Texas Forensic Science Commission.
But why are these things being thrown out? Is there a particular error rate that they exceed? Does anyone even know error rates?
When they eventually started doing studies of them, they found such high error rates that they said, whoa, we can't be doing this.
Well, what's an example that you've seen that jumped out at you?
In one of them, they took, I believe it was 100 pictures of wounds, good high-quality pictures of the kind that a forensic dentist would take. So they showed a large number of board-certified forensic dentists these photographs of wounds in flesh. And I'm calling them wounds because they might or might not be bite marks. If they are bite marks, they might not be human. And the experts were all over the map just on that, just on saying, is that wound a bite mark or not a bite mark? They disagreed quite a lot on that. Of those who agreed it was a bite mark, if you said, is it human or animal bite, they disagreed on that. Of those who agreed that it was a human bite mark, if you said to them, is there enough information in that bite, kind of like what you referred to earlier as a large enough sample? Do we have enough in the bite mark, in the flesh? Do we have enough of the biter's dentition that you could try to do a match? They disagreed on that. This is even before they say, well, which individual out of the thousands, tens of thousands of people out in the community who might have been the murderer, which one is it? They couldn't get even, before you even got to that point, they already were showing such a high degree of inaccuracy that, or let's say disagreement, they can't all be right. If some say it's a human bite, some say it's not even a bite wound. So Texas has been the first that said we won't be allowing that in our courts in the future, or until you get a lot better. These things aren't necessarily, even the ones that are thrown out are not necessarily thrown out forever. It's that more work is needed. The reason we've found ourselves in this situation where we quite belatedly are trying to figure out which of these techniques is dependable and which are not is our forensic science didn't grow up in industry or academic labs. It grew up in police agencies where they didn't know about research, and they didn't have time for research. They've got cases they need to solve. And so you have a good idea and you run with it, before you've done all the testing. We wouldn't do this with drugs. Oh, I have a great idea. This drug will cure things. Let's go with it. No, we say we got to see some sound research.
But this is tough. Like, let's say you're doing bite marks, okay? So if you were to teach people in a course, this is what you should look for, and this means this, that, and the other, then of course, that's what you would get if you did a test of quote unquote experts, if they all received similar training. But, if there's, let's say bite marks, you could actually do physical measurements. And if they're, if the profile of the bite is within a millimeter of, a certain person's dentition and they have these 7 matching features, then maybe, okay, the bite does match. But it's weird, like if you try to teach any of the learnings, it seems to reinforce maybe the error. I don't know if I'm using you in the right terms and everything, but does that answer what I'm saying? Is like, you have to be careful it doesn't become a tautology this way, and so therefore that's what you'll come up with.
You're describing a degree of measurement of the bite, the dentition of the suspect and the bite as a kind of measurement that I don't think they actually were using. And I'm not sure how helpful that would be. What they would do is they would actually try, it would be like if you dropped a coffee mug and then you tried to fit the pieces back together, you could do a pretty good job of figuring out that jigsaw puzzle. They would take a mold of a suspect's teeth and they would actually take it and physically try to match it to the wound in the victim at the morgue.
Right, but that's assuming like a person would bite fully with the upper and lower engaged and all the fine purchase on this. The nature of the fat and the skin and how it moves under pressure and deformation would be known. And I mean, it's just, it seems like there's tons and tons of factors.
That has been a lot of the problem. How, when you are in a fight with somebody and you're biting, their skin is also stretching twisting in different ways. So that then when you take your teeth away, the skin, its elasticity puts it back to how the skin was, and the teeth will no longer match, and maybe someone else's teeth will match. Skin is a very bad substrate for trying to record a bite. Your dentist, when they want to make a crown or something, they use way, way, way better materials for capturing that tooth's shape. So it's a very shaky business, but they acted like we can adjust for that. And if you only have one suspect and one victim and you think they match, you are then unaware of how many other people's teeth would match. In England, where they save a lot of they don't just move on to the next case. They save the old dentition, the molds. A British forensic dentist once showed me 5 different sets of teeth that matched a crime scene bite mark equally well. That's a good illustration of what I was talking about earlier of the best we really can do is to say this suspect cannot be ruled out as the contributor of the handwriting, the bite marks, the whatever. They're in a pool, a small pool. We don't know how small the pool is, but it's not a pool of one. Another way they discovered that bite marks were a problem was that the forensic dentist would say, your suspect is the biter. And then when the DNA analysis came back, it would exclude suspect A. And this was happening too often. It was happening often enough that the forensic dentists started adopting a practice of not turning in their report until after they found out what the DNA showed, because they didn't want another instance of being proven wrong.
I wonder if people in the industry would say reality bites as a measure.
But I would say progress is happening. I think younger forensic scientists are much more into research. We've got NIST with a lot of people they have different committees working on different forensic sciences. As I said, some of the weakest of them have been thrown out. So I'm something of an optimist that the future, I'm still one of those people who thinks we'll do better in the future we've done in the past.
What forensic techniques seem to be really robust and have held up to scrutiny and, testing and studies and all that?
Well, we used to say fingerprints were the gold standard. Now we say DNA is the gold standard. partly because it comes automatically with a measure of its own accuracy or inaccuracy. They are now working on doing that with fingerprints. There have been researchers hard at work trying to be able to say something more meaningful about the random match probability of fingerprints. But, even that is tricky because the fingerprints at the crime scene are frequently, they're nothing like what you see on TV. They are partial prints, they are smudged, they are dirty. So there are some famous examples of fingerprint errors where they said that's the guy, turned out not to be the guy. But let's see, which ones would I say are really good? I'm actually looking at we have a chapter on each one of these things. I'd say fingerprints, when you have the more nearly full the print, or if you have multiple prints. Again, this gets back to your very good insight about how large is the sample of the material you've got. If you've got several good fingerprints, then I would have a lot of confidence in the expert's conclusion. If you have a fragmentary smudged print that's been laid on top of other prints, then that I think would be very worrisome. I think fire and arson has gotten better because they've been testing the arson indicators as they had not. I don't know the state of handwriting and bite marks at the bottom of today's, the ones that are still being practiced. I think Texas is the first, but not the last state that will end up tossing that out.
Are there any new forensic methods that are like really, really in the nascent stage but show promise?
I'm not the person to ask. I do old-fashioned low-tech. I don't even do it. I look at studies of the old-fashioned low-tech forensic science for the most part. I have heard, here's what I've heard, I don't know how good it is, but I think people are working on it. The idea is that when a person passes through a room, they pick up particles in the air. There might be pollen, dust, maybe even gases in the air. And let's say that is a room, and different rooms, if they can do this, you could be able to examine a person, vacuum off what's on them, have some other kind of sniffers. If the room had some combination of gases, this level of nitrogen, or maybe there had been natural gas stove burning. And if you got them soon enough after the crime, you might be able to say that there is a meaningful probability that that person, that suspect, had been in that room where you found the victim's dead body. Now, that at the moment, let's say it's a hypothesis or it's a science fiction scenario. But that would be interesting if that could be done. I know there are a few other, let's say, forward-thinking ideas, but I can't think of what they are. But none of them are ready for prime time. It may turn out that we're not going to need very much of this in the future because we will all be monitored so thoroughly that you won't, kind of like, I'm sure you saw Tom Cruise in Minority Report.
Right, yeah.
It may be that nobody will be able to go anywhere in society without being under surveillance. So anything we do, they'll be able to figure out who did it. Or you'll have to do some very complicated things like Tom Cruise did to try to evade detection.
Right. Okay. Well, very good. Well, Michael, what's the best place for people to find out more about your work, and where can they get your forensics book?
Well, I think they could go to Amazon for the book. Actually, it's 5 volumes, Modern Scientific Evidence. There's only 1 volume on forensics, though. But they could find that at West Thompson West Publishing or Amazon, or ask your local bookstore. They can find me on the Arizona State University website.
Okay, very good. I thought that would be very funny is instead of you doing a book signing, what if you did like a book biting? You went to you wrote your name, best of luck, and then you bit the book so you'd have a bite mark and you gave a fingerprint or something on the book. It'd be kind of funny.
Yeah, maybe we should do that. Instead of my signature, I'll give you my fingerprint. Actually, maybe that's dangerous.
Well, very good. Well, thanks so much for coming on the podcast. I didn't know the state of forensics was so fraught with error, but it's really important to what you spoke about. And again, thank you for coming.
Well, thank you for having me. You take care.
Thank you for listening to the Good Question Podcast. Please email support@thegoodquestionpodcast.com if you have any referrals to great guests for us to interview. Visit thegoodquestionpodcast.com to hear more interviews. And please help us spread the word by rating and reviewing us on Apple Podcasts, iTunes, Spotify, YouTube, or wherever you listen to this podcast.